Sweta madam, is it audible to you?
Yes, sir.
Lavanya madam, shall we start?
Yes, sir.
TV Rao sir, good afternoon.
Sir, good afternoon. I will share it, sir, my presentation. Just wait, sir. Sir, am I visible to you? My screen?
Yes, sir.
Okay. I will start whenever you tell me start. My voice is also clear. Audio.
Sir, TV Rao sir, good afternoon.
Good afternoon, sir.
Sorry, sir, here due to net problem, it is disconnected, sir. Sir, once you stop your screen sharing, sir, we have to introduce you before the starting of session.
Okay. Okay, sir.
Yeah, thank you, sir. Thank you very much. Good afternoon to one and all. A warm welcome to second day of this online 1 week faculty development program on advancements in construction materials and practices. Now I take a privilege to welcome today's speaker, respected Dr. T. Venkateshwar Rao sir. He is a renowned personality, popularly known as Dr. T.V. Rao. He is going to explain an importance of civil engineering in electrical power transmission. Before start the session, I request Mrs. G. Sweta Madam, Assistant Professor, Civil Engineering, to introduce the speaker. All the very best to all of you and happy learning.
Good afternoon, one and all. Dr. T. Venkateshwar Rao garu is presently working as Executive Engineer in Transco Department, Telangana State. He did his PhD in civil engineering from JNU Hyderabad. Prior to this, he completed his MTech in structural engineering and BTech in civil engineering. He has vast experience in design of structures in high tension electrical power substations and foundation transmission towers in the rivers, construction and maintenance of civil engineering works of substation and transmission towers. He has published many research papers in various Scopus journals and conferences. He has renewed personality, popularly known as Dr. T.V. Rao, because he has participated in many TV show programs, debate programs as part of Jana Vijnana Vedika. Welcome you, sir.
Thank you, madam.
Sir, please start the session, sir.
Okay. Good afternoon, everyone. I am T.V. Rao. I am working in TS Transco. Previously, I worked in different sectors. That is, when the power sector is combined as APSCB, I worked in generating stations, distribution companies, and finally in transmission corporation. Actually, everyone thinks that power sector is not for civil engineers, but most of the civil engineering, even huge structures on large scale, they are actually in generating stations, like cooling towers, turbo generator foundations, chimneys, almost 210 meters height chimneys. Remaining structures also holding the boiler structure pylons and other ball mills structures, everything. All those civil engineering structures are really challenging, and we can learn many aspects of design. Before coming to the power transmission, I'm showing one picture. In that power station, that power station is the generating station. The generated power will be transmitted to the end user as consumers at the end of the power transmission. So first, initially, the power generated will be stepped up to these powers, that is, voltage will be stepped up by a transformer to transmit the power to the distant substations. This step up is needed to reduce the power loss, that is I square R losses. The power, the voltage will be increased to 132 kV, 220 kV, 400 kV, and 765 kV in India. If it is 765 kV, the line losses will be less. So our role, that is in transmission corporation, we deal with the 132 kV, 220 kV, 400 kV, and 765 kV. For the residences, we need 230 volts. For the apartments who are having transformer, that will be supplied with the 11 kV. So we reduce the power to 33 kV or 11 kV to the distribution company. The distribution company will supply the power to you 11 kV or 230 volts. 11 kV means 11 kilovolts, 33 kilovolts, 132 kilovolts. Like that, the power will be stepped up at the generating stations, and it will be transmitted to the distribution substations. So meanwhile, we deal with the transmission towers, erection of towers, and mainly I deal with the foundations. This is the tower. These towers usually the height ranges from 70 meters to 100 meters. Mainly river crossing towers, they are having a height of 88 meters. That is, while transmitting the power, we come across the rivers also. Okay. We come across the rivers also. So there we need special structures in the rivers. The load coming onto the conductors from one tower to another tower, there will be a span of 300 to 350 meters. When it crosses a river, it will be 850 to 1000 meters. The span between towers is 850 to 1000 meters. But on ground, it will be 300 to 350 meters. Usually, the tower will have 4 legs. In those 4 legs, 2 legs will be either in compression or uplift or tension, downward force or uplift force, in addition to the lateral forces. The magnitude of each of these forces depend on the type of tower and the transmission capacity of lines. Basic design requirements: the tower foundation should take care of all the loads such as dead loads, live loads, wind loads, seismic loads, and erection loads. Mainly in Telangana and Andhra Pradesh, we consider dead load, live load, and wind loads, and erection loads. It is not displaying nature of loads. The same thing, nature of loads means while considering this dead load, usually the structure and the dead load of conductors, the dead load of other accessories, all will be considered. And for live load during operation, very minor live loads will be taken, and other loadings, that is erection loads. While stringing, we will consider additional loads. The towers will be carried sometimes through helicopters also after erection of structure on ground. It will be carried towards the hills, and there during that time also we will consider the erection loads and wind loads. Wind loads on conductors, wind loads on structure parts, wind loads on suspenders and other accessories. These are the loads. basically while designing the foundations, towers may fail due to uplift only. Major damage is due to uplift force. Uplift force is due to the wind force. So here we design of foundations need the following limit bearing capacity of soil, density of soil, angle of earth frustum, that is the angle of internal friction. Here when the upward force is acting on the stub is the angle which is inserted in the foundation, that IS section transfers the load to the soil above the foundation. So to sustain the uplift force, we will consider the weight of the concrete and weight of the soil above the foundation, considering the angle of internal friction. If the soil is not having angle of internal friction, if it is 0 or it is less, then the width of the foundation will increase or depth of the foundation will also increase. So that is mainly for the uplift force. Dead weight of the structure is very less, and compression due to wind force will also be considered, and the failure due to settlement will be checked for the bearing capacity of the soil. So mainly the towers fail due to the failure while uprooting the tower, while due to wind forces only. When we design the towers across the rivers, sometimes we have to keep the towers in the river. That is, we design foundations keeping the tower parts above the maximum flood level. That is the tie beam which is coming below the tower, that will be kept above the maximum flood level. Because during floods, it carries heavy size logs or trunks of the trees. They may hit the tower portion, that is steel structure, because the steel structure is designed for either tension or compression. It will not take any bending forces. That's why we keep the steel structure above the maximum flood level. Remaining portion, concrete portion, will be designed for all the forces, wind currents and unexpected hit by the huge logs also. This is this is one of the tower designed by me. It is in Godavari River at Ellampalli, Telangana, and other structures I designed across the Godavari near Ravulpalam, Rajahmundry, and another tower across the Krishna River in Vijayawada, and another tower, two lines near Jorala, downstream of the Jorala project, Jorala Dam. So there are seeing the structure, the concrete structure at Jorala, I didn't consider this tie beam at the top. I designed it as a cantilever from the ground. So that is also one type of design, but I am unable to present that photograph here. These are the structures they are designed by me. Failure of foundations. The failure of foundations of transmission towers. Failure of tower foundations have usually been associated with certain deficiencies either in the design or classification of soils or construction of foundations or deterioration. Usually the failure is due to the classification of soil means improper decision while that is soil classification means I will show the details. Classification of soil, that term is used in transmission corporation, but usually it is not found in our soil mechanics. That is throughout the world. To save the time, the designers, the department gives a classification for the soils to speed up the project, and the standard set of designs will be supplied to the field engineers. That's why this terminology, classification of soil, is not associated with the general books of soil mechanics, but it is related to the transmission corporation only. Even in GENCO also, it will not be given. Every structure will be designed specifically based on the soil properties only. But here we will have a classification of soil for the abstractness of some of the designs. So construction failures also one of the reason, and deterioration. Failure of foundations of transmission towers. The foundation may fail visibly or invisibly. The failure of foundation is visible when the foundation gets uprooted in part or as a whole. The failure of foundation may not be visible when settlement of foundation takes place. Apparently, there may not be damage to the structure of foundation, but this settlement causes eccentricity in loading and buckling of tower members. Chances of failure. The chances of failure due to design deficiency are comparatively less to and deterioration of tower or foundation. Design deficiency. The design deficiency will be derived out of overestimation of design parameters or underestimation of design loads. The design parameters like safe bearing capacity of soil, soil density, angle of repose, maximum depth of foundation have to be well within limits. Design and detailing deficiency. The structural designer who designs the structure has to clearly show the details of the reinforcement. The field engineers sometimes they cannot understand the development length considered by the designer. Here in this picture, the red color arrow is showing one bar that is just beyond the vertical face of the pedestal. So most of the engineers, they approximately keep the bar to that extent only. Then it will, when the uplift force is acting on the foundation, the top reinforcement will come into action, and due to the insufficiency of the development length, it will crack as shown in the picture. That usually that will happen when the field engineer is unable to understand the drawing. Design and detailing deficiency regarding the leg that is on angle, IS angle, that is inserted in the foundation. it should be properly given what is the depth to be inserted in the foundation, bottom of the footing, and the cleat. This is one tower collapse adjacent to a small channel. Because of flash floods occurred due to the sudden collapse of the water tank at a higher elevation. So this is the trunk of palm tree that was uprooted when the flash flood occurred. It hit the leg of the tower, and this almost that entire tower collapsed, and for almost 15 days there was no power to 15 villages. So that happened because they have not considered the maximum flood level due to the flash floods occurred due to the collapse of the failure of the sudden breach of the water tank before this channel. So that is one failure. The tower is on the bank of the Wagu only, but it is not properly elevated. That structure should be, the steel structure should be above the maximum flood level. So because they didn't consider that factor, due to the sudden flash floods, the uprooted palm tree hit the legs of the transmission tower. This is a 220 kV line tower collapse. This is due to the failure of foundation. But most of the people don't know how to analyze the collapse is due to the collapse of the steel structure, failure of steel structure, or due to the foundation concrete. So here this is to be analyzed there. See, there is a gap between the soil and the, usually we call it as chimney, but for your convenience, I say it is a foundation column, support pedestal. If there is a gap between the soil and the concrete, then it is the failure of the foundation only. The two legs which are on the leeward side, they will, those two legs only separated from the original portion from the soil, and other two legs they have not separated because they are under compression, and these two legs are under tension, uplift. So failure occurred due to the uplift on two legs. The center of gravity of the concrete structure, that is the chimney, should match with the center of gravity of the stub. Stub is IS angle. Sometimes they may not erect properly. That is one failure. That is construction deficiency. This is another construction deficiency. Improper concreting, improper shaping of formwork. This is the example. Uplift resistance. How to estimate the weight of the soil above the foundation. In some places, when we excavate the soil, it will show a dry condition of soil. If we consider the dry condition, soil density will be considered as around 1600 and 1690, like that, depending upon the soil, whether it is gravel or normal soils. But if there is water, then the parameters will change. So if the soil is black cotton soil, the angle of internal friction will be 0. Then the soil above the foundation needs to be increased. So the width of foundation, we will increase the width of foundation, and we will design for that size the overburden weight of the soil. So there are different conditions. Here, suppose if we consider the dry condition of the soil as shown in the left side of the picture, it may change to a submerged condition also. Submerged condition or partially submerged, or the water table may rise. In Telangana, it happened now. Previously, in Telangana, water table will be very low, and during crops only there will be water on the ground, but remaining seasons the water table will be very low. But after the formation of Telangana, many lift irrigation schemes are constructed, and the water supplied to the fields and the groundwater table raised, and there are many check dams also. So the towers constructed before 2014, they are designed as taking the soil condition as in dry condition. Now the towers are in submerged condition. So the condition changed. So we have to redesign the foundation, or we have to strengthen the foundations. So that is the task now we are doing, because in some places it is partially submerged, and in some places fully submerged, and in some cases the towers are inundated above ground level more than 1 meter. So the condition changed. The tower may fail at any moment during rainy seasons because of the wind force. The wind force will be maximum from July to October. So the failure may occur during that periods because of the uplift force. Why is it happening? The density of soil, which we considered after backfilling, the strength will, if originally it may be around 900 kg per cubic meter, the density of soil. When it is submerged, the density of soil reduces. Density of soil reduces means because of water table, the concrete weight will also reduce. Initially, when we consider it as dry, as shown in left side figure. We consider the weight of concrete as 24 kilonewtons, with reinforcement 25 kilonewtons, and the soil density 1690 kg per cubic meter. Now, on the left side, when the water table is there up to a certain height, then the concrete weight will be reduced from 24 kilonewtons to 14 kilonewtons. It happens due to the buoyancy. So simply, when there is an uplift of 1000 kilonewtons, we designed considering 24 kilonewtons concrete weight and 1690 kg per cubic meter soil weight. Both are reduced. That is 24 kilonewtons become 14 and 1690 becomes 690. Almost 40% weight is reduced. So when there is an uplift of 1000 kilonewtons, there is a resistance of only 600 kilonewtons approximately. So automatically the tower may uproot from the base of the soil. So these are the conditions now happening in Telangana. So we are rectifying all those foundations. Recently, Telangana became #1 rice paddy producer in the country. Previously, Punjab. Now, Telangana is the #1, and water supply for the paddy fields is abundantly. They are supplying and both the seasons. That's why the trouble is for the transmission towers. So this is the main factor, main trouble to the transmission towers. In some places, we are constructing retaining walls to retain the earth also. This is the case for the towers on the river. You know, when the river flows during floods, it covers the bed and the sides of the bank also. When we do the soil investigation, we may observe the bed level at one place, but during other seasons it may go down due to the velocity of the river water. So it depends upon the scouring depth. The depth of scouring depends on the size of the grain of the soil and cohesion also. So velocity, it depends on velocity, size of the grain, and cohesion forces in the soil. So that will be calculated, that scouring depth will be calculated while designing the foundation based on the IRC code 5. That depth, the same code, that IRC code will be used for the bridges also. Same thing will be considered in designing the foundations of the transmission towers crossing the rivers. If it is not considered, that cover depth is not considered, then the problem will be like this. This is the tower laid on the riverbed, but due to the deficiency of design, that is, they have not considered this cover erosion of bed. So the foundations are exposed. the foundation which we inserted the piles below the bed level, they were exposed due to the covering of the bed. Then the pile caps are tilted. So the tower is ready to collapse. There are other failures also. While considering the wind force, the direction of wind force, we have to consider in 3 directions. Parallel to the conductors, perpendicular to the conductors, and diagonal to the tower. If there is a when we consider the diagonal direction of wind force, one leg will be in uplift, that is tension, and another leg will be under compression. In the diagonally opposite legs will be in neutral condition. This is the uprooted foundation. Other 3 legs are safe, but one leg is uprooted. This is because of the improper design and considering the soil properties also. Sometimes it may happen in the built-up soils. Foundation is good. Concreting is done in a standard form, and it is good. But the design, wind load design, and another factor is soil parameters. Hudud cyclone, during Hudud cyclone in Vizag also, there are many failures of towers in different ways due to wind force. The failures are different. The failure occurred due to the missing members in the towers. At the base, concrete and tower connection. It was the emergency work. So the towers erected on the tower parts were carried from the airport to hilly area using a helicopter, and they erected the parts on the hill slope like this. Sometimes erection of tower will be completed on the ground, and it will be carried by the helicopter, and it will be erected and kept in position on the hill slope. These are the failures. This is the only failure due to compression. Usually, for any design of tower, usually it fails in uplift only, but this tower leg pushed the foundation into the soil. This is one failure in Hudud cyclone. This is also uprooted leg. So, very difficult task is laying foundations in hard rock. The locations where chiseling, drilling, and blasting are required for the sheet rock excavation, we adopt hard rock type foundations. Actually, the expenditure is very less for the foundation on hard rock, but the laying is very difficult, and usually the construction agency has to carefully excavate the hard rock portion, and they have to check the thickness of the rock should be at least 3 meters. Otherwise, we should not go for hard rock foundation. For these foundations, rock anchoring is to be provided to resist uplift forces. See, when we want to have a foundation for the tower on hard rock, the sheet thickness should be 3 meters. This is the foundation, because there should we lay the foundation depth as 1.5 meters, maximum 1.6 meters. So below that, at least there should be a rock portion of 1.4 meters. Otherwise, for the downward thrust, it punches the hard rock. If it is less than 1.5 meters, that foundation will punch the hard rock into the soft soil. That's why we specify 3 meters thickness of sheet rock. Even for buildings also, we need to check there should be at least 3 meters thickness of hard rock. Otherwise, we should not go for foundation on hard rock, considering it as giving good resistance to the downward force. See, like this, even if we get hard rock after 2.5 meters depth of soil, if we find this hard rock portion at 2.5 meters, also we prefer hard rock foundation, because it consumes very less concrete and gives high resistance to the uplift and downward force. Usually this is the foundation, right side top, that is the cross section details. Maximum 1.2 to 1.5 meters and horizontal, this one also. Here we consider the bond stress between the hard rock and concrete. That is 4 kg per square centimeter. That resistance will be calculated at the bottom and sides. So to get that force, we will increase the size of the excavation also. That is while designing. This is one more foundation. If the force is not, suppose if we don't get the sufficient force by excavating itself, we go for anchoring. Foundations on hard rock anchor type. Additional, if you need additional force to counter the uplift force, we anchor the foundation to the hard rock. That is also by drilling holes and grouting the rods. Excavation is very difficult in hard rock, and most of the contractors, they blast the concrete. If they blast the concrete using gelatin stick, then the strength of the concrete will be disturbed, and the designer considered 4 kg per square centimeters, but the actual force will be below 1.5 kg per square centimeter if they excavate using gelatin sticks. That's why the following procedure shall be adopted while executing the excavation of pits in hard rocks. The sides of the pits shall be vertical. The stub length, stub means the angle which is, comes from the tower leg, that is steel structure, IS angle. The stub length may be cut suitably without disturbing the anchorage value specified by tower designer, and concrete the pits as specified in the foundation drawings. So there should be minimum damage to the foundation. Blasting may damage and loosen the final rock surfaces at the perimeter and bottom of the excavation. Although this damage cannot be eliminated completely, in most cases it can be limited by using controlled blasting techniques. The more common of these techniques are pre-splitting, smooth blasting, cushion blasting, and line drilling. Pre-splitting of rock. When pre-splitting, a line of closely spaced holes is drilled and blasted along the excavation line prior to the main blast. This process creates a fracture plane between the holes that dissipates the energy from the main blast and protects the rock beyond the excavation limits from damage. Drawing. What is pre-splitting of rock? Smooth blasting method. For the smooth blasting method, the main excavation is completed to within a few feet of the excavation perimeter. A line of perimeter holes is then drilled, loaded with light charges, and fired to remove the remaining rock. This method delivers much less shock and hence less damage to the final excavation surface than pre-splitting or conventional blasting due to the light perimeter loads and the high degree of relief provided by the open face. I will explain in the picture, this one. Cushion blasting. I think you might have seen while excavating hard rock in Hyderabad for the 40-storied buildings or 10-storied buildings. They use cushion blasting. Cushion blasting is basically the same as smooth blasting. However, the hole diameter is substantially greater than the charge diameter. The annulus is either left empty or filled with stemming. Line drilling method. When using the line drilling method, primary blasting is done to within 2 or 3 drill hole rows from the final excavation line. A line of holes is then drilled along the excavation line at a spacing of 2 to 4 times their diameter and left unloaded. This creates a plane of weakness to which the main blast can break. This plane also reflects some of the shock from the main blast. The last rows of blast holes for the main blast are drilled at reduced spacing and are lightly loaded. Line drilling is often used to form corners when pre-splitting is used on the remainder of the excavation. This picture. Actually, without this line drilling, most of the contractors, they execute directly by drilling a hole at the center and they insert the gelatin stick and they blast it. If they blast it like that, the cracks will propagate in different directions and it spoils the strength of the hard rock. So we have to utilize the power of the hard rock. We have to utilize the strength of the hard rock. So to utilize the strength of the hard rock, we have to follow these steps, the line drilling method. Initially, we have to drill holes as shown in the figure, and spacing will be a line drilling with 25 mm dia holes using compressor at 100 mm center to center. If we drill like that using compressor, a line of crack will be developed along the holes. So it will be separated from the main rock portion from the excavated portion. So there should be two lines. One square inside, one square is there, and another one is actual requirement of excavation. Outside line is for the actual line of excavation. So after doing this, we have to drill hole at the center of the foundation, and we have to charge it for blasting. Then it will not, the cracks will not propagate beyond the line of excavation. That is the procedure. After doing some blasting, then slowly we can remove the portion of the rock by pushing it towards the center. So one face empty will be available at the center. Then excavation of rock is very easy. So this procedure should be followed while excavating the hard rock foundations. Minimize damage to the final foundation grade. To minimize damage to the final foundation grade, generally blast holes should not extend below grade, that is towards ground also. In the previous picture, we discussed about the propagation of cracks horizontally. This slide is explaining about the propagation of cracks to the bottom. When approaching final grade, the rock should be removed in shallow lifts. Charge weight and hole spacing should also be decreased to prevent damage to the final surface. Any final trimming can be done with light charges, jackhammers, rippers, or other equipment. Actually, these things are not available in the books available in India also. These are procured from the military design of the American military books. They follow this procedure. Here in India, we are having excavation of hard rock for tunnels. There are many books, but for excavation of foundation for hard rock for the transmission lines, we are having very less literature available for to suit the Indian conditions. In certain types of materials such as hard massive rock, it may be necessary to extend blast holes below final grade to obtain sufficient rock breakage to excavate to final grade. This procedure will normally result in overbreak below the final grade. Loose rock fragments and overbreak. Prior to placing concrete or some types of embankment material, all loose rock fragments and overbreak must be removed to the standard. The over excavated areas are then backfilled with concrete of sufficient strength. Bond stress, as I have already explained, that is 4 kg per square centimeter. If we proceed with the procedure explained previously, we will get the bond strength of 4 kg per square centimeter. So pile foundations with cast in situ board piles for power transmission lines. Most of the engineers get doubt how can we lay foundations in perennial rivers. We will form a island, and over that island we carry the equipment and we lay the foundations. This is the equipment for the. See, we form the island formation for the water locations, that is in river. Initially we drive the bullies as shown in the figure. Outside and inside, there are two rectangles. Those two rectangles will be formed by driving wooden bellies into the sand, and they will be tied with the bamboos horizontally, or bamboos or bellies, and in between these two rows, we fill the gap with sandbags or sand. So after filling the entire portion inside rectangle will be filled with this sand. So island will be formed. After formation of the island, according to this drawing, that is pile foundation for the tower. For each leg, there will be 4 to 9 piles. So the pile diameter will be 2 meters, and each pile below each pile cap. This is the pile cap, and there will be 9 piles like this below each pile cap. The diameter of the pile is 2 meters. Bundling of reinforcement will also be seen in the picture. Machinery in bore drilling. That is the hammer which drives the casing pipe into the soil, into the sand. This casing pipe will be the length of the depth of the casing pipe. It depends upon the availability of the stiff clay. If the stiff clay is below 10 meters or 12 meters or 16 meters, up to that depth, even for the 16 meters or 20 meters, the casing pipe will be MS iron casing pipe will be driven into the soil. Then the soil and the water will be bailed out from the casing pipe. Then after completing the further expansion below the casing, that is from stiff clay to the hard rock, or if the hard rock is not available, it will be driven up to the required strength. So then after that, the casing will be kept in the hole. This case, reinforcement of the pipe, this will be kept into the borehole. Next, concreting will be done through tremie pipe to avoid the segregation of concrete. Now the standards are different. Previously we used M20 grade. Now we should use M30 grade only. And reinforcement standards also changed. And the slump. So, bentonite solution will also be used to avoid the collapse of the sides of the borehole. Completed pile foundation. There are different types of pile foundations on the riverbed, depending upon the capacity of the tower. Sometimes on hilly areas, we do micro piling. If the very hard rock is available on the hills, complete solid screws type, that is HVASD steel piling, that will be done by drilling holes into the hard rock. Thank you. If you ask doubts, I will explain. May I close this presentation?
Yes, sir. Please stop the sharing, sir.
Okay, sir.
Sir, Dr. K.V. Rao, this is Satyanarayana from State Department, sir.
Uh,
Sir, I
sir,
have, sir, shall you take any
just wait, sir. Just wait. Actually, I am unable to close this one.
Okay.
Okay. Tell me, sir.
Sir, shall you take any precaution measures for Torontos also, sir, while you are designing of any electrical towers?
Which factor you are saying?
Toronto, sir. Sudigal and Chudandi.
Tornadoes or hudhud, that is also a whirlwind or whirlwind. We faced it whirlwind, not tornadoes. That also we will consider, sir. We have to take many precautions. If the tower location comes in between the hills also, the wind velocity will be doubled or tripled.
Okay.
That also we have to calculate based on the suppose if we stand below the on the cellar on the stilt floor of an apartment, we face we observe some change of velocity before the apartment and below the apartment. So the change is due to the cross-sectional area of passing the air will change. So then automatically A1 V1 is equal to A2 V2. That also we have to calculate in between the hills. That is more dangerous.
Because powers.
There will be turbulence because of the shape of the hills also.
Yes, sir. What about the topographical changes, sir?
That also we have to consider, sir. As shown in the wind, our code on wind loads, the same thing we will consider. And additional thing is we have to study the terrain and how the turbulence may create at the tower location. That also we have to consider. As you said, whirlwind, that is we faced in Vizag during Hudhud. That is completely whirlwind, not tornado. That is whirlwind. Only it has taken away the plants and towers, but not other things.
Okay, sir. Thank you, sir. Thank you for your explanation.
Thank you.
Any questions, please? Dear participants, please ask your questions.
సార్ నమస్కారం అండి.
Namaste, sir. Chappan, sir.
పేరు జంజాల నారాయణ మూర్తి. Sir, this considering Telangana, I'm sure the transmission line length will be maybe in thousands of kilometers, isn't it, sir, put together?
Yes, sir.
So the number of towers, depending on what is the minimum distance, will be in maybe, if not in lakhs, it will be in thousands. So how do you actually go about doing periodic inspection as such, sir? I mean, what sort of cycles do you have?
There is completely separate wing for each circle. They will monitor they will check regularly. That is, they will check the position of the tower and during rains also they will go and check. And before the rainy season, we have to check for the damage due to the inundation. So this is the dry period now, because after winter, we can clearly see the tower parts which are inundated in the water, and we have to check those parts, and we have to do anti-corrosive paints to the tower parts and foundations. After rainy seasons, we have to check it, and during rainy season also, during floods, we have to check continuously. And emergency duty, that is, we have to protect the tower from the flooding. So during nights also we work for that, and before that also we estimate the damage and we protect the towers by constructing protection walls and catchment drains. We divert the water coming from the fields. Sometimes if there is any change of usage in the paddy fields, suppose most of the people nowadays they are doing fish ponds. So if they do fish ponds without our notice, then definitely damage will occur to the tower, because they fill the tank, fill the area with completely water, and that water will be above the foundation level. That is, it may be around 2 meters. So previously we considered it as a dry soil condition. Now it will be under fully submerged condition. Then the foundation size we have to increase 4 times. So if we are unable to change the size of the foundation, we will change the direction. We will change the location of the tower. So completely we shift the line. Parallelly we shift the line also.
Right, sir. Thank you, sir. Thank you.
Sir, welcome, sir. I think I have completed early. Actually, I am having slides of more than 350 slides, but I thought many questions will come, and I reduced it to 90 slides only.
But then quite informative pictures, sir. I mean,
Sir.
there are the real pictures you have shown. So it's quite nice.
Still, there are many innovations while doing designs to suit the capability of the contractor's availability and equipment availability. Suppose in coastal area we are having pile foundation experts. In Telangana there are no pile foundation experts. That is pile drilling. For huge structures, they are bringing the people from coastal area, but because of the interior, most of the people, even black cotton soils are also previously they are in dry condition. They didn't face much problem. Now, even buildings, even compound walls, they are facing a lot of problem because of the raised water table in Telangana. Because of the raised water table in Telangana, the soil below the foundations, if it is black cotton soil, it is swelling and it is disturbing the foundations, and the compound walls are also collapsing, and buildings are also developing cracks. The same thing happening for the towers also. So this is the main observation after bifurcation of state. Telangana has a great development in water supply to the paddy fields because of the check dams and lift irrigation schemes. So the same problem we are facing with the towers also. So completely designs, we have to change the designs, or we have to shift the lines, or we have to protect the tower foundations by making additional arrangements, additional downward force for protection of towers from uplift force. We have to anchor the foundation.
Namaste, sir.
Sir, namaste, sir.
Okay, sir. Shall I ask?
Please ask.
So I'm Dr. Mohammad Hussain,
Sir.
professor here. Actually, before you construct, so do you do modeling? Because in all our dams, before I worked in irrigation department. So
Yes,
before we construct the dam, So
I
we do
think
modeling, how it
you have
behaves.
worked on this. You have
At least,
worked on
do you do
CCTV.
at least mathematical modeling, ANSYS modeling? Will you do that, sir?
Actually, it will be done at the SCRC, sir. SCRC and other places for power research center. At Uppal also there is a power research center. There they will do all these experiments for a new type of foundation. I think you have worked in irrigation department as deputy executive engineer. I think.
You know me?
I know, sir. I had met long back. I think maybe.
I see. And incidentally, I got selected in 86 for electricity board.
Sir.
By that time, I already joined irrigation department.
Yes, yes.
I was posted to the Vijayawada Dharan Power Station. My batch retired. All 86, those who are joined.
86, they are going to retire within 1 year, sir. Almost many of the engineers retired. Here
So they became SCs and Cs, civil engineers.
So chief engineer, most of them are chief engineers.
Oh, very good.
Your batch, 1986 batch, our chief engineer is from 1986 batch.
Oh, my batch.
Electrical engineer.
Electrical engineer.
In Karimnagar.
I see. So you are doing this modeling, sir, actually? Using modeling and all.
Central Board of Irrigation and Power, that is in Delhi, they will do all these experiments and they will make a book after completing those works. That is that may be that consolidation will be by Central Board of Irrigation and Power, but the work will be done at different places. Power research centers are there. So that is the one is at Uppal and other places in Chennai, Gujarat. So that modeling will be done and they will check the courses also. But practically, just like pile loading, we will do sample pile capacity, that is anchor capacity. All those things will be done at the actual location.
Okay, sir. Thank you very much.
Okay, sir. Okay, sir. Thank you, sir.
All the best.
Sir, myself, I have one small question.
Sir, please ask.
Generally, what is the height of the tower and the distance between two towers do we provide, sir?
On ground, it is usually 300 to 350 meters.
Okay.
When it is crossing the river, it will be between 850 meters to 1000 meters.
Okay.
Sometimes we will consider 1200 meters also. If it is the capacity of the tower, that is, if it is 132 kV.
Okay.
So if it is beyond 1200 meters, we need a location in the river. Usually Godavari river is very wide. So we need towers on the river bed. Okay.
Height, sir? Height of the tower?
88 meters, sir. It will be called as Jamuna Crossing River, JC Tower. So first they have designed while crossing the Jamuna. Jamuna means Yamuna.
Okay.
So that will be called as JC Tower.
Okay.
Usually we are going for that only till now. There is no change.
So generally material we are using is GA, no sir? It's not undergoing any corrosion like that.
Tower parts are highly galvanized.
Yes, sir.
Highly galvanized.
Because it is always subjected to weathering actions. No, sir. Corrosion effect means a big headache.
Actually, while doing this bolting, when they tight, if there is an improper tightening of tower boards,
yes,
there
sir.
also starts rusting. So
yes, sir.
Just Dr. Janjala asked that question. So usually our people will inspect regularly, that is periodically. maybe 2 months. For every 2 months, they have to
Okay.
verify each tower. So daily they will be on that job only, patrolling of
Okay.
towers.
Okay, okay. Thank you, sir.
That's-
So, any questions, please?
This is Shweta from Civil Department, sir.
Madam.
Sir, I have one question. What will be the governing forces in design of foundations of transition towers?
Main force is uplift force, madam. What are the loads means? Load is wind load is the main load that is causing major forces. Other forces, other things are very minor. Only
The
wind
lateral
force.
forces are very minor, sir. Lateral and
Lateral forces are due to wind loads.
okay, okay. Sir. If it
That
is
is-
combination, sir.
Combination as shown in the our design, regular design.
Okay, okay, sir.
Live load DL plus LL plus wind load
Hmm.
or seismic load. So same thing.
Generally, we are not considering seismic loads in.
Tower design, we don't go for seismic design because wind load is maximum.
Yeah.
And it is an seismic design will be considered only in some areas. In Andhra Pradesh and Telangana, we are not considered.
Okay. Thank you.
Thank you.
Any questions, please? Sir, one question is there in chat box, sir. Shall I read, sir?
Please read, sir.
Sir, the concept of tower is still followed in Western countries, or they have a different mode of transmission?
Actually, mono towers, they are using monopoles. Monopoles they are using in China and other countries. And recently, in the outer ring road, we adopted these monopoles. You can observe while passing through the financial district and other areas, we used monopoles instead of towers.
Yes, sir.
Because space trust will occupy more area. So it is completely based on economics only. If the land is available, we will use tower. If there is no land and insufficient space and demand is more, then we go for monopoles, completely hollow steel sections, usually imported from China only. So those monopoles we will use for the higher elevations and in cities.
Okay. Okay. Any other question, please?
Even in Vijayawada also, we have adopted monopoles.
Okay.
What is the other question?
What is one more question, sir? Sir, is there any pump storage plants? Any pump storage plants are there in our region?
Pumped storage in Telangana, we are pumping the water from the bottom to the upward areas. That is, suppose if we collect water at Kaleswaram, from that place we are pumping upwards. So, suppose in Godavari, Gangaram, that is in Khammam, the Warangal area, we are pumping water through 14 reservoirs. So not only existing reservoirs, we are constructing balancing reservoir near Pulkurti, Janagam area. So there completely Telangana depends on pumped storage only. Reverse pumping, that is the river flows far below the level of the paddy fields. That's why we are Telangana is unable to have gravity type of irrigation. So completely we are lifting the water and then adapting the gravity force.
Okay. Any questions, please?
Sir, good afternoon, sir.
Good
Sir,
afternoon,
this is
sir.
Ramadhanelu from CVR College of Engineering, Hyderabad, sir.
Sir.
Sir, thank you for elaborative lecture on transmission towers. Sir, I have question like this. How to select site for a transmission tower foundation or construction of transmission tower?
It is completely based. Initially, we select the locations. That is, we have to suppose we have to supply the power from Kottagudem Thermal Power Station to Hyderabad. So, if that is the project, first we draw a line from Kottagudem to Hyderabad, a straight line.
Okay.
That is called B line. So then we study the topography. If there is a forest, we try to avoid the forest. If we are unable to avoid the forest, we apply, we request the forest department to give weight for the power line. So because if you want to lay the power line through forest, we have to remove the trees up to a width of 70 meters on the complete length. So that is one aspect. And if there is any pond or any colony, if there is any city, any town, we have to divert the line. So completely, suppose if the distance is 200 kilometers straight line, usually the line length will be more. The line length will be more than the 200 kilometers. Approximately, it may go beyond 260 kilometers. So that is the deviation of 30% deviation from B line. We call it as B line, straight line. So that is due to the restrictions. If there is any habitation, we have to divert the line. That is the procedure. Are you satisfied?
Are you there, Ramadhanel, sir? I think
that is your question.
I think there is a net problem, sir.
Okay. Another question.
For a transmission tower, the land required is procured or leased, as they sometimes pass through agriculture feeds. Land procurement.
Actually, that is a big problem, sir. Very good question, but completely previously, before 2003 Electricity Act, we can lay foundation without the permission of the landowner. That is that comes under the Telecommunications Act. Now, after 2003, new economic policies. Because of those new economic policies, the Electricity Act is changed from the service provided to the profit-oriented organization. So, because it is doing commercial activity by getting 3% profit, so we should not lay without paying any paisa to the farmer, landowner. We have to pay 85% of the cost of the land passing through the, that is, we calculate it as 70 meters into length of the line passing through the agricultural field. So that land will be converted into acres, and we have to pay 85% of the cost to the farmer. But the landowner is the farmer only, but we have to pay the amount because we are doing the business. But most of the farmers, they don't know. That's why we are exploiting.
Okay. Any more questions, please? Okay, I think there are no other questions, sir.
Okay, sir. Okay, thank you.
Thank you very much, sir. Even though you are very busy, you spent your valuable time and you shared your experience on design parameters of towers, failure of foundations, and about the pile foundations. You explained very well, sir. Thank you once again. Thank you very much, sir.
Welcome, sir. Thank you. Thank you, Ananda.
Okay. Vivek, sir, shall we end the session? Okay, sir.
Okay,
Thank
sir.
you.
Thank you.
Hmm. Dear participants, please join by the same time tomorrow.